everybody. So as you all know, I'm doing the videos on PG Physics. This will be helpful for you for the preparation of JL entrance exams as well as TS set notifications. TS set, the notifications which have released recently. Now you all are familiar with the syllabus for set teaching aptitude. Okay. Next, along teaching aptitude, you also require the subject. This subject will be asked as more deeper questions and simpler questions. So for preparing for either for TS set or JL exam, it is better to be perfect with degree physics as well as the PG physics. So for degree physics, follow the old versions of unified physics. Unified physics are excellent books which give the complete information about one particular topic, and it is easy understandable to you all. Right? And next, for PG physics, my best suggestion is to follow Upkar series. This is useful for JL physics, the complete JL physics and TS set syllabus is covered by Upkar series. Alright. So now in Upkar series you will find some number of questions for practice. Okay. So it is little bit harder to learn, but if we want to gain something, we have to do hard work. So follow this Upkars series. So complete syllabus of JL physics as well as TS set is covered in this Upkar series. And now in my videos what I am doing means, in some videos you will find the general question answer. Orally you can learn. Just note down while you are listening my video. And in other some videos I am teaching the each and every model related to mathematical physics. From each model I am giving only one example so that you can understand how to do that particular method. Okay. So now welcome to my channel Reshma Physics. In today's video, let us go for some bits. Okay. A general bits which will be helpful for you in your exams. Now the oral preparation is enough for that. Okay. As I already said, in case of vectors, we need to know some fundamentals. Already in my first video of mathematical physics, I explained about that fundamental formula such as curl formula, A cross B equal to, we call it as curl. Okay. So cross product we call it as curl, dot product we call it as divergence, we will write it as del dot A. Okay, here curl we will write it as curl A, that is del cross A, in such a way. You just watch my first video on mathematical physics. You will get some fundamental formulas related to the vectors. Now let us continue. A vector field which can be expressed as a negative gradient. So as negative gradient of scalar, such as we will write d minus del pi, where pi is the scalar. Okay, how we call it as lamellar field. What we will call? We will call it as lamellar field. If we write any vector field which can be expressed as negative gradient of a scalar field. Then we call it as lamellar field. Now next, the amount of flux diverging from a point per unit area per second, we call it as divergence of vector field. Right? We call it as divergence of vector field. Do you know what are the flux lines? Right? So I will explain. Now flux lines means, now I took this, let us assume as an vector field. Now I am assuming one particular vector quantity. Vector quantity means what? That particular quantity which explains about the magnitude as well as direction, velocity, acceleration. They have magnitude as well as direction. Now I took one such vector field. Now let us assume that vector quantity, one quantity in this particular vector field, this paper let us assume as vector field, is traveling from A to B, B to C, C to D in such a way. Now let us trace the path of these points A to B, B to C, C to A. When you trace the path, you will get either straight lines or curved lines. Right? So this imaginary straight lines or curved lines drawn along a path of vector quantity traveling in a vector field, we call it as flux lines, or we can also call it as line of flow. Right? Also we can call it as line of flow. So an imaginary line drawn along the path travelled by a physical quantity or a vector quantity. Here physical quantity we are taking vector. We call it as flux lines. Now let us assume these are the flux lines. They have particular direction. Then only we can call it as vector. Now to this flow of flux lines, perpendicular to the flow of flux lines, I assumed an area. Okay, I assumed an area perpendicular to the flow of flux lines. Now the flux lines entering to this area, the number of flux lines entering to this area, we call it as divergence of vector field, and mathematically it is wrote as, if A is the vector field, we write it as del dot A. We represent with dot product. Right? This we call it as divergence of vector field, the number of flux lines. So what he said, the amount of flux diverging, okay, here entering or leaving. Leaving, that itself we call diverging. So the amount of flux diverging from a point per unit area per second, we call it as divergence of vector field. Now next we are defining the curl of vector field. Right? We are defining the curl of a vector field. The line integral of a vector per unit area along the boundary of infinitesimal area. Now I draw the area now. If we take a line integral along that area, then we call it as curl of vector field. So do you know what are the line integrals? Now we call it as line integral. If A is the vector, we write it as A dot dr. Right? Where dr may be dx or dy or dz. Line integral. Surface integral. The integral taken along the surface, we write it as A dot ds. This is the line integral taken along a curved line or a straight lines. Now the integration along a surface. Here the value of ds will be dx dy. Area means length into breadth, no? Or dy dz or dz dx or dz dx. Alright. Now next, volume integral. Integral taken along the entire volume of the surface. We will write it as volume integral, that is triple integral A dot dv. That is, here dv is equal to entire volume, length into breadth into height, dx dy dz. Right? In such a way we will write. If we take any line integral along a unit area of a vector, then we call it as curl of vector field. Now curl is represented with cross product. I said no, del cross A. A field is irrotational. Irrotation. The curl general meaning means, curl means rotation. Curl means rotation, the general English meaning. So now here he is saying field is irrotational, no? Field is irrotational means there is no curl. So a field is irrotational if curl A equal to 0. When there is no curl, field will not rotate. If curl is there only, field will rotate, because curl means rotation. So when curl A equal to 0, field is irrotational. Now next, solenoid. So when we will say this, you have to remember. When we will say a vector field is solenoid, when divergence is equal to 0, divergence of vector, that is del dot A equal to 0. It will be very useful for doing your mathematical parts. So irrotational means curl A equal to 0. Solenoid means del dot A equal to 0. Now the direction of grad phi is normal to the level of surface. The direction of grad phi is normal to the level of surface. Now next, if r is the position vector, then curl r equal to 0. If r is the position vector, then curl r is equal to 0. Remember a simple formula. Or you can do, what is r? xi plus yj plus zk, no, the position vector. Now how we will find the values? I will write here. You can do it. Generally r is the position vector, xi plus yj plus zk, no. He is saying curl r, his value is 0. How we will write curl r? Right? I, j, k. Okay. Dou by dou x, dou by dou y, dou by dou z. X, y, z. R equal to xi plus yj plus z. I know. That only I wrote. Now first, remove row and column. Dou z by dou y. This is with respect to y. So 0. This is with respect to z. So here y is there. 0. How we will write? Dou y by I into dou by dou y z minus dou by dou z of y. 0. In such a way, if we take j or k also, we will get 0. You once practice, you will get. Right? Now next, if the line integral of vector field depends only upon the coordinates of 2 points in the field, and is independent of actual field, we call it as conservative. Means, now only I said no, if we trace the path, any object, let us assume that it started from A and its destination is B. Its destination is B. Then what he is saying? The line integral of any vector field depends upon these 2 points only. So between these 2 points we can move in such a way. We can move in such a way. We can move in such a way. Right? So number of ways will be there to reach to B, from A to B. So whatever the way we are choosing, our intention is to reach B. So the line integral of vector field depends upon only on this initial and final points and independent of actual path. Then we call it as conservative field. Vector field is conservative in nature, we call. For example, you want to go from your home to market. From home to market, you will not have only one way, no? You may have some 2-3 ways to reach the market from your home. Here your intention is to start from home, go to market. In which path you are going is not important. Just you are reaching market or not, that is important. And from market you are coming to home again or not, that is important. So here the line integral along the vector field depends only on these initial and final points, but doesn't depends upon this actual path. So then we say the field are conservative in nature. Right? Now next question. Remember this. So I think in my videos I did one problem on Gauss divergence theorem also. So what is Gauss divergence theorem? Gauss divergence theorem. So it gives the relationship between surface integral and volume integral. In such a way we will write, if A is the vector, surface integral A dot ds equal to volume integral del dot A dv. And Stokes theorem we are having. So Stokes theorem gives the relationship between line integral closed curve, integral along the closed curve, line integral and surface integral. So we will write it as integral A dot dr equal to surface integral del cross A ds. Okay. And next, the condition that vector A should be curl of vector function. The condition that vector A should be curl of vector function. We will write if del dot A equal to 0, then vector will be the curl of a vector function. Right? These are the some of the bits, the oral bits, easier bits which may be asked in the entrance exam. Now in my next video, I will do in upcoming video some general normal bits on matrices. Right? So if you like my video, if you think this matter is useful for your entrance exam preparation, like it, share it, subscribe it and recommend along all JL as well as TS set aspirants. Thank you.